Now we're going to test spark plug wires. Some common symptoms of bad spark plug wires are engine misfires, rough idling, poor fuel economy, difficulty starting the engine, especially in cold weather, low engine performance, and can also cause electrical interference, which affect electronic components of the vehicle if their insulation is worn or damaged, and others. When testing spark plug wires, you should test wire resistance, wire insulation, and check if they are routed correctly. The maximum resistance of a spark plug wire shouldn't be more than 10,000 ohms per foot. That's about 30 centimeters, but some OEMs have different maximum recommendations, so it's better to check your owner's manual. You should only test each wire separately. Only when you finish testing and reconnecting the wire, continue to the next one, so you won't mix their firing order and potentially damage the engine. This is 38 centimeters. Set the multimeter on 20k ohms. Touch the multimeter leads together. They should read about 0 to 3 ohms to make sure the multimeter is working properly. Connect the multimeter leads to each end of the spark plug wire. Make sure they touch the metal contacts. If the multimeter lead won't reach the metal contact, you can use a screwdriver after you test it to make sure it's not insulated. It should read around 0 ohms. Now, start to wiggle the wire to make sure the reading is steady, especially the first number. If it starts bouncing or breaks, then the spark plug wire is faulty and its internal conductor is broken. Here the reading is about 6.5 kilo ohms per 1.25 foot, which is good for this vehicle recommendations. Now testing the wire insulation. Make sure the wire is clean. Start by visual inspection. Check for signs of damage or wear such as cracks, cuts, burns, and corrosion inside the boot. Also check the clips that hold the wire into the distributor. Bad clips can allow wires to move from their position. When you reconnect the wire to its place, continue to the next one. Now checking for shorts, you need a properly insulated test light. Connecting it to metal ground and positive terminal of the battery to make sure it's working. While the test light is attached to a metal ground, start the engine, move it along each wire, and check if a spark arc from the wire to the test light, or the test light illuminates. Now the mist test. This test is better to be done in a dark or dimly lit area. Use a water mist bottle to lightly spray water over the spark plug wires. Be careful not to soak the wires, just a light mist is sufficient. Start the engine in the dark, and observe the wires for any signs of sparking or flashes. Also listen for a snapping noise that might indicate an electrical arcing. Check the spark plug wires if they are routed correctly according to your owner's manual. This prevents cross-coupling, which can lead to energy drain, low engine performance, misfires, and engine damage. Only a few manufacturers allow cross-coupling to reduce radio frequency interference and electromagnetic interference, but not wires of consecutively firing cylinders. And don't forget the spark plugs. If they are bad and have a higher resistance than what's recommended, they require more power to fire and can put extra strain on the spark plug wires and their insulation, potentially causing damage over time. To test the spark plug, remove it and set the multimeter on 20k ohms. Check if the multimeter is working properly. Connect one probe to the terminal of the spark plug and the other to the center electrode. In general, spark plugs with internal resistor, which are used for vehicles, should have maximum resistance of 10,000 ohms. However, the exact ohm number depends on the make and model of the vehicle.